Hello, everyone. Thank you for joining us for today's webinar. My name is Zuri Garcia, and I will be your host for today. For any questions you may have during the presentation, please use the Q&A function throughout the webinar, and our speaker will do his best to answer them at the end of the presentation. For today's webinar, James Bates will be speaking about the basics of AI and how it is impacting healthcare. James Bates is a CEO, entrepreneur, and board member that has created and led high-growth plans for various companies. Currently, he's CEO and founder of Adveno Medical, the world's first artificial intelligence and augmented reality-driven automated medical visit platform. Previously, he has been an officer at Freescale and XP and was responsible for $1 billion in revenues. Additionally, he founded the Asia Pacific region for Silicon Labs, where he drove more than $500 million in revenue. James has a Master of Science degree in electrical engineering from Brigham Young University. Furthermore, he is fluent in Japanese, holds 9 patents, and has written in the Proceedings of the International Geoscience and Remote Sensing Symposium. Now I would like to pass the presentation to James. Thank you.
Hello, thank you for taking the time with me today. I'm excited to be able to share Adveno Medical AI. Let me get this up and running. So as was mentioned in my previous job, I was at a company called Freescale. I did self-driving vehicle technologies. We made the technologies that gave the car the ability to sense the world around you and be able to take action with that world. When you start looking at the opportunities that brings, of course, artificial intelligence combined with self-driving vehicles enables a whole new world that frees people from a certain location and allows goods to be moved at very, very low cost. But in December of 2015, we sold that business. And as an officer of the company, it was my time to retire. And as I retired, I started looking at other places to go in. And I decided to invest in healthcare medical practices. As healthcare practices, there were a lot of issues. It's one of the greatest issues of our time. How do you take care of people and give them the healthcare that they need? However, as I was looking at the business of healthcare, I couldn't bring myself to invest. It has a lot of different issues associated with actually making money. So if you're a surgeon and you do surgeries all day, you make a lot of money. If you're a health insurance company, you make a lot of money. If you're a doctor just seeing patients, you don't really make very much money. And that is the whole fundamental problem with healthcare today. So as I started looking at this as an investor, I couldn't bring myself to invest. But then I took a step back and I thought, okay, what if we use the same concept of automating around a driver in a car and we automate around the doctor in the clinic and we completely automate that experience? Will that actually deliver an experience for patients and doctors inside the clinic that people would enjoy? And more importantly, does the business of healthcare automatically become possible for everyone to do? And the answer is yes, it does. So that was the foundation of Adveno Medical and kind of how we got started. Let me go ahead and share my screen. What I will be doing today is going through and talking about artificial intelligence, what the fundamental artificial intelligence is, and then give the example of healthcare and how we ended up where we are today. All right. So this is what's called a hype cycle from Gartner. And this actually uses the hype cycle for artificial intelligence. There is a tremendous amount of hype around artificial intelligence. And this is 2019. And what you can see on here is that there is a lot of different technologies which we hear a lot about. It starts with innovation that triggers a possibility. And then there is peak of inflated expectations. That's where people hear so much about these technologies and they have all great ideas. Then they realize it's a lot harder to do than what we think, and it turns into the trough of disillusionment. And as you move farther up, the technologies advance, they become more mature, and that's when you have the slope of enlightenment and where you can actually start seeing these technologies move along. And then you have the plateau of productivity where the technologies are meeting their full possibilities to be used in society. Looking at this graph, you see some things like GPU accelerators sitting in the plateau of productivity. Why? Because graphics processors are everywhere. They're in your phone, they're in your TV, they're in your car, they're in essentially all parts of our economy. Thus, they are in that plateau of productivity. We're not expecting them to change much, but they're now a part of what everybody does. Speech recognition also kind of falls into that category. Not really natural language processing, as you can see, is still sitting between peak of inflated expectations and trough of disillusionment. But ultimately, the computer being able to understand my dictates, not interpret it, but be able to do a speech to text or text to speech, is very much mature technology. So if we go back and we look at other technologies that are out there, what you see is Edge AI, which people talk about a lot. That's still sitting in the innovation trigger because GPUs have become so cheap and so prevalent. But what you see are chatbots are at the peak of inflated expectations, where everyone is expecting the chatbot to fundamentally change the world. And really, chatbots are just starting to be used. Natural language processing, self-driving vehicles, robotic process automation, computer vision. People are basically tired of hearing about this stuff. And that's why it's sitting in the trough of disillusionment. This is what everybody hears about. But really, what is AI? So when you start thinking about it, artificial intelligence is a number of things, but it is not any one of these things alone. So at the very center, you have to have technologies. This is a physical enablement. This is like a computer, a GPU. There is a platform, some type of user interface. There are the APIs associated with it. All of this is the physical piece of any artificial intelligence system, but it's not AI on its own, although many companies claim that it is. Then you have the ability to reason. This is an if, then that, some type of decision tree, maybe some simple AI logic that will predict an outcome given data. But this in and of itself is not AI either. Now, you can't have the methods without the technologies. Then you have the ability to learn. A lot of people think, oh, now you have the ability to learn, you are AI. Well, yes and no. You have, in order for a system to be able to learn, you need to have technologies, you need to have the methods, and then you can learn. But if you cannot communicate with the outside world where you can engage and observe, then you do not have the AI as it is defined. So artificial intelligence, what is it really? Artificial intelligence is the ability to sense, reason, engage, and learn. All of these items are what AI is all about. So if you want to engage, this is the NLP, natural language processing, computer vision. This is engaging with the outside world, voice recognition, robotics, planning optimization software, capturing knowledge. All of this is engaging with the outside world. Learning has supervised and unsupervised learning. We're going to talk a little bit about this and why it's going to matter to you. So first, what is supervised and unsupervised learning? Supervised learning is when you take a computer and you feed it data and you tell it that this data is similar, and the computer then says, hey, it does pattern matching and says, if it's similar, it must be the same. So what you see in the picture here, you'd say this is an apple. You put in a picture of an apple. Then you write, these are apples. You put in a whole bunch of apples, and then you feed it something that it doesn't know. It says, hey, it looks like an apple. And so it says, hey, we are an apple. That means an expert has essentially defined what the computer is seeing and then has spit out an outcome. Unsupervised learning is a little bit different. This is where we have input data. That input data is not defined by a human. It is fed into the model. The model actually will extract the things that are similar among all of these different images. Whether it's an apple or a peach or a banana, it's all put into its own little characteristic mapping within the neural network. Thus, this model will know, hey, this is this. We don't know what it is, but it looks the same as all of these, so it goes here. Thus, a human is not an expert in what it is. It's just pulling out things that are similar. Often, you will hear a term called deep learning, big data. This is often what they are referring to. Most of it is unsupervised learning, where they're looking for matches and characteristics that they didn't know were really there and that they believe will help run businesses more efficiently. Another concept which I think is kind of important is, how does a system learn? In this example, you have a nice little brain, and this is going to take an action. It takes it out to the environment, and let's just call it a dog learning to sit. So you would go to the dog, you would tell the dog to sit, maybe you push on its bottom a little bit, the dog sits. The dog understands that, then you define a reward, you give it a treat, the dog wants the treat. Thus, over time, as you do this multiple times, you give it food, you tell it to sit, the dog sits, you sees the dog sits, then you give it food, this positive reinforcement. Very easy concept. We all use it with our children, with our pets, and pretty much in everything we do. There's positive and negative reinforcement that we use. Well, a computer does this with mathematics. It either strengthens a correlation or weakens a correlation based off of an outcome of the environment on an action that was taken. So when we look at it within the framework of a neural network, we could get to see exactly how this works. In this example, you have an image of a cat, and a algorithm like TensorFlow or something like that will take this image and it will break it into different layers that have different similar traits. And they don't know which traits it's grabbing on. It's just looking for traits that are similar among a number of different images. And it can be as big as the color of the cat and the color of the background, or as small as the cat nose, which is what we're talking about in this picture here. Thus, if we grab this little layer, we could say, wait a minute, this layer has the very tip of the cat's nose. The next layer is that little discoloration after the cat's nose. The next layer is that little area between the cat's nose and the mouth. And the last area goes into the cat's mouth in the bottom. This is it demonstrates the level of accuracy and the level of detail that these models are pulling out as it's comparing images. Now, this is done without human intervention. Generally, humans can influence what characteristics the classifiers are actually being created under. But ultimately, what's happening as each one of these processes move through, the more pictures, these get stronger or weaker. This is reinforcement learning as it's putting it in and mapping in a unsupervised way. The amazing thing here is that intelligence is everywhere. It is obvious to us. Maybe it's robots or drones or autonomous vehicles, something that we can touch and feel in the physical realm. Maybe it's obvious, but it's virtual, like a chatbot or a virtual assistant or a smart advisor, things that we all see today. Maybe it's not so easy to see, like an intelligent sensor. Maybe it's your Ring doorbell that recognizes when people come in. You don't even know about it, but Ring remembers it and puts it into their system. Maybe it is in the very back end of your smart security operations that's learning about attacks real time by tracking the IP addresses that are hitting your website. This AI is being used in almost all aspects of our life today, and it will only continue. Now, us as entrepreneurs or advisors, we as board members of companies, our job is to make sure that we are early adopters so that we do not lose our advantages as other companies start automating pieces of their workflow. I'll just go through a simple example of healthcare. The interesting thing with healthcare is that everybody knows what the problem is. It's like the guy going to see the doctor with a big arrow shot in his head. And the doctor goes up to him, sees that massive hole in his head, and just says, "What seems to be the problem, sir?" This guy's looking back at the doctor and saying, "Well, everybody knows I got this arrow in my head." In the United States, per capita spending in healthcare has just skyrocketed out of control. It's got to the point where the average family is spending $20,000 a year in healthcare maintenance. When you're paying $1,500 to $2,000 a month for insurance, that's when you know something is fundamentally wrong. The problem is that ultimately clinics are going bankrupt. You see them close all the time. And there's a shortage out there. At the same time, clinics are closing. The reason is because they're not making money. And the system is not allowing them to make money. Ultimately, the people who are paying the price are the patients. If you live in a large metro like Boston, you could be waiting up to 2 months to see your primary care doctor. And depending on the type of specialty, you're waiting up to a month when you start looking at any of these cities throughout the United States. We hear politicians talk about this all the time. And on one side of the aisle, you have the people that say the government should pay for it all. They're the solution. On the other side of the aisle, you hear the people say that the government is the problem. Just let anyone do medicine and it will be fine. The reality is neither of these are the solution. And we know that, which is why it hasn't been solved today. The only way we can actually really solve the problem is by getting to know the stakeholders, getting to know why the motivations are there, and then using technology to deliver a true solution to the marketplace. These competing motivations, whether it's payers, health systems, providers, they're not enemies. But in our system today, they compete against each other to grab that healthcare dollar. So, how do we approach this? Using artificial intelligence and augmented reality, we can actually automate the whole patient experience, eliminating waste. Today, healthcare clinics essentially have a tremendous amount of waste as they have become data collection centers rather than patient service centers. In fact, 2/3 of the time providers spend is wasted. And that creates tremendous profitability struggles for the clinics that are out there in the marketplace. Whether it's documentation that they have to collect, whether it's getting the right billing codes, or whether it's treating patients over virtual consultations, all of these are leading to a tremendous amount of wasted time. And that ends up creating the problem that we have. The AdviNow solution resolves these issues by two main applications, one that faces the patient and one that faces the doctor. On the patient-facing application, we use artificial intelligence and augmented reality to collect all the information from the patient that a doctor would need to make a diagnosis and treatment. On the doctor-facing application, we present that information to the doctor in a simple one-page format that allows them to complete a thorough objective diagnosis in a flash. This is why we say that these doctors have superpowers. And these superpowers are 2 times throughput. Doctors that used to see 3.5 patients an hour now see 7 patients an hour. Doctors, the patients have higher than 90% patient satisfaction, near perfect accuracy, and ultimately improved outcomes. This whole process is what is driving the revolution in healthcare. The amazing thing here is that no industry is immune. All industries are now tech industries. Whether this is in a hospital, like I just talked about, or whether this is in a car, drivers, whether it's in a factory being replaced by robots. Artificial intelligence is here to stay. And for us as leaders in the technology industry and in industries that maybe aren't traditionally technology savvy, and we can go into construction industries or farming industries, things like this, they now are technology-centered industries. So I would invite all of you to go through and create activities for you and your own industries to separate out 2 types of tasks. One, which we call repetitive task identification. These are not complex tasks, but they are repetitive tasks that a human is doing every day. Many times, a good example of this would be paying invoices. AbbVie now receives invoices in the mail, we receive invoices over email, and we receive invoices through other applications like a QuickBooks. And a human takes that information and then we put it into our accounting platform. Using robotic process automation, we've developed a system that reads all of these invoices and automatically populates them into our accounting system, and a human just comes in and reviews the accuracy. That is the type of robotic process automation that we as business leaders must always do. The second piece is complex decision identification. That is automation around a person. So when you think about your business, you're going to think about one thing, that one person, that if you had 10 of those people, your business would just take off like crazy and be super profitable. Then you think about everything that that person does that essentially somebody else could do. Now, a lot of times you add people to do that. What we're talking about in these type of exercises is taking these complex decision identification and automating around that liability owner. In AbbVie case, we are automating around the doctor, machine learning, artificial intelligence. This system, how this works, is exactly how the AbbVie system will make doctors more efficient. We eliminate the need for them to ask the patient a bunch of questions. We eliminate the need for them to actually document that information into the EMR. AbbVie system helps the doctor see more patients, not by making them do more work, but by eliminating the work that has less value for them to do. I would ask all of you to go out into your own companies and find a complex decision maker that you can look at and see if you can increase the efficiency of to make them better at what they do. Once you've done this, then you have to identify the data that you could train using supervised and unsupervised learning to be able to help automate around that liability owner. This is how AI is changing the world. This is how startups are revolutionizing industries. And whether we're a startup founder looking for something to do, or we are an actual business owner trying to make sure we're competitive and take market share, this task of identifying repetitive tasks and complex decision makers is required of all of us as we are entering the new age of artificial intelligence. So, to the answer to the very first question, is artificial intelligence hype real? The answer is yes, it is very real. And what does it mean for my business? Ultimately, your business will be changed by it. And it will either be changed by you or by your competitors who are eating your lunch. My name is James Bates. I am from AbbVie Medical. I am open to any questions you may have. That is the end of my presentation.